This video is going to give you a simple math understanding of what half-life is. So in my example, I'm going to start with a cube of silver, but let's talk about what half-life actually is defined as. It's the time it takes for the amount of radioactive nuclei to be reduced by half through some decay process. So whatever I have after amount of half-life time, I have half as much. If all that makes sense. Let's go with an example and kind of show you how it works. So when we talk about half-life, we're also talking about kind of like a coin flip, a 50-50% probability of something converting over to a different material. So let's take a look at this example. The decay time for 1/10⁻47 silver is 25 seconds. If a sample starts with 400 grams, how much of this isotope remains after 75 seconds? So when I'm looking at this, 25 seconds is the half-life, and I'm asking about 75 seconds. That's going to be 3 half-lives. So let's kind of work it out just step by step. I'm going to start by making a little table with the half-life, the time, and the mass that I have at that half-life. And the left-hand side, I'm going to make all these spheres. So there's 16 spheres here, and they represent the total amount of silver in this block that is 1/1047 silver. At a half-life of 0, my time is my starting time, so that's going to be 0, and I start with 400 grams. The first half-life, you can see that my block goes down. It's not like magic where when you have a half-life it disappears. It's just that what I have in this block, only half as much 1/1047 silver is left, but there's still something there. So it's not like a magic thing where it disappears. It's just converted over inside of it. And my spheres on the left, I've gone from 16 to 8 because I have half as many. And now I'm at 1 half-life. So 1 half-life, that's going to be 25 seconds. And after 25 seconds, I have half as much as I previously had. So I have half of 400. Great. Now let's look at a second half-life. Kind of work it out this way. Again, left-hand side, look at the spheres. I've gone from 8 to 4, and that represents the number of atoms that are 1/1047 silver. And at my second half-life, I have 2 times 25, or 50 seconds has gone by, and I have half as much as my previous half-life. So previously I had 200 grams of 1/1047 silver. Now I have 100 grams. All right, still looking for my question. How much remains after 75 seconds? Let's go one more trial. And so you can see on the left, I've got these spheres, these green spheres. And so the amount of 1/10⁻47 silver, you can kind of see how it's going down each time, half as much as the previous half-life. And in my little block cube that I have in the middle, you can see that I have a smaller amount at the bottom. It's a lighter gray. And my half-life, well, this is the third half-life. So now that's 75 seconds when I add up all my half-lives. And half of my previous is now remaining. So I went from 400, half of that was 200, half of that was 100, half of that is now 50. So after 3 half-lives, or 75 seconds, I now have 50 grams. So while I'm here, and I've answered the questions, 50 grams are left after 75 seconds. Let's take a look at what I have on the left-hand side of the paper. So if I look at this and connect all those top spheres, you can see I have this curve, and this is an exponential curve. And so if I go so far as actually put it on a graph and kind of move it over, what I'm looking at on the bottom axis, the horizontal axis, is the time in seconds. And the vertical, I'm looking at the amount of the original isotope that I have, and that would be the top left-hand side would be the starting amount.